our favorite artist electronics, Mr. Q12 here, and I'm testing some MOSFETs right now. A single MOSFET actually, you can see it here. And I come to the realization that I need for this kind of test that I'm performing here. I will make another movie about it, not right now. Right now I'm talking about power supplies. What I worked with until now, I worked with this power supply that I'm having here, and I'm powering this 12 volts that you see on this wire, this logic circuitry down to the gate. This white wire here is to the gate of this transistor, and another power supply that is coming through this resistor and this transistor, and I'm measuring across it from my variable power supply, switch mode power supply that I'm having there. And I'm underlining, emphasizing switch mode power supply because it is actually having a switch mode output, I believe. The output that is coming through these two wires is switched probably through another MOSFET or some kind of some sort of circuitry that is outputting, and is not really a good thing. It's not a good thing to test with this switch mode power supply that I'm having here. I just dig a little bit through my stuff that I'm having, and this is definitely made many years ago, but the transformer is looking like it's brand new, almost like it's brand new. This case that you are seeing here is over the tolls, over the transformer core that transformer core is looking new, brand new. That's what I'm, you see this metallic, shiny transformer core, steel core that is surrounding the wire core that you are seeing here. So, and I didn't test it. I have no idea if it's even working. It should work because I was having it stacked there, and probably at some point in my life I made this circuitry and I use it probably, or my father or somebody made it and used it, but I don't actually remember what I did every day of my life, and I don't remember specifically this one where it came from, if I actually use it or not, me personally. But for some reason I'm having it there, and it's having a very dubious construction. It is clearly from the 80s or the 90s is made. It is almost written on it the way it is made very cheaply with it's made in home. As you can see, this is aluminum, and these are actually two diodes. Here is a diode and this is another diode, power diodes they are. And before powering I looked at how is wiring is going, and all this mess of wiring that you are seeing here, what they signify, what they mean, and I managed to figure it out what they mean, every wire connection, and I will describe it very quickly right now. Do you see this cable here that is coming through here between the the coils of the transformer, and is terminating here with these two wire ends here and there, and is coming between the transformer winding, and you can see is a knot here, and then it's terminating here with this end and here with this end, you see, and then so from this white wire, and then is going through this red one, and then through this red one, and so basically this red ones is the primary of this transformer that is going to this wire that I'm having here. So that's these two wires demystify what they mean, and they are on the lower side. As you can see, they are on the lower side of the transformer there. Nothing else, not another wire is coming from there. Only these two wires that are winded into those holes, that hole and that hole, and that's it. On this top side, I'm having this wire here that is going down there, you see, and is winded a little bit here. And here is another wire that is coming through this isolation tube and is linked here. And this, the third one, that is not connected to anything and is actually is secured by this tube isolation tube here, not to make contact on its end. I know I'm making this kind of isolations myself. That's why I'm very undecisive if I build this shit or not. When I was very young and when I was experimenting with transformers, actually I didn't do too much experimentation, unfortunately, because the stuff was quite expensive for my Romanian pockets, and I couldn't afford back in the 90s too much things. But this probably I managed to procure it from somewhere. And so this is the wiring side, what is doing. So it's having two wires coming on this line, this white wire here, and another two wires here to these elements. Down here is this one that is catched in that screw there, and here is on this diode here. And I actually measured the diodes. This is a defect multimeter for voltage measurements. It will show me erroneous voltage, but for other functions it is like it's new. It's not deranged. I tested it, and it's only having an issue on the voltmeter side, unfortunately. And I love this. I truly love this voltmeter, but yeah, I did some stupid stuff with it probably. Okay, so to test the diodes, I already test them, and I know if I'm touching their body here, and its end, and I'm getting that 450, let's say 470 millivolts is actually there, what is showing. And here as well, 470. They are very well matched, these two, very well matched. They shouldn't be that well matched, but they are. And if I'm measuring like this, like here, come on, yeah, it's the same, you see? And here, this is my wire testing device, and it's beeping if I'm making a short, but unfortunately it's putting 9 volts here from the battery that I'm having here. Is only good for wiring, but not for components. But if you are testing components, diodes are okay to test. This is positive, the yellow, this is negative, polarized. So now I'm testing the between this aluminum element and the body of the diode, and here is the same. Okay, and this is the polarity, and this is not working like this, and this again is the polarity, and this is not working. So it's okay to put 9 volts over a diode, especially from a battery, and to test wiring and connections. But I am very careful with it, because this is a stupid, very stupid tester. If you forget its intention and you put it in a important circuit like that, and you start testing stuff for conductivity, for and you can very easily burn a chip or a very sensitive component that you have there. Okay, so that's this is how it's looking at this point. So my thought, my thinking right now is to take out these two abominations that I'm having here, because let me actually draw it for you what I'm having here. Actually, this was made for 220 volts because it's very old, and we had 220 volts a long time ago. And here is the alternative ends, contacts, and this is the primary, from primary, and this is the wire core, which is that one there, and this is the secondary here. And from what I'm seeing there, is having 3 wires, and is having a middle one, probably is the half of this two, probably, most probably. Usually it's like that, or a certain percentage from that, probably a 9 and a 12, or a 6 and a 12 volts, most probably. I didn't check it if it's even working. I didn't test anything. I didn't read anything from it. I got stumbled by this all this stuff that is having here, and I try to understand what is doing. And probably here is having this diode here, and here is this diode is inverse, and these two wires, these two ends are these two wires that I'm having here, and they are extremely long, and they are very, very, very long. And I will take them out, and what I will do, so here is the secondary, here is the secondary, so this is the secondary. I will put a rectifying bridge here, because with this configuration that I'm having here, and I really don't like it, and I have a ton of rectifying bridges, quite powerful actually. I have different sizes of rectifying bridges, this one, and this ones as well. So this kind of rectifying bridge that you're seeing here, actually let me show you a brand new one. This is scrapped one, and probably I will use it. I'll use this one. Then I have very powerful ones, even bigger than that, you see, even bigger than that, like this, but it is not needed here. This rectifying bridge model, brand new, by the way, these are brand new. They were extremely cheap, extremely cheap. Probably I gave $1 or $2 on all of this, and I took them. And also these guys, like you're seeing here, and I'm also having very, very small ones, but I don't see them here. Yeah, I have them here. I have them here. Yeah, here, bridge rectifiers, and these are SMD, you see, versions, also very cheap, very, very cheap. And yeah, so these are the bridge rectifiers that I'm having, and I will probably, I could use this one probably and have no problems, but I will use a beefier one, because I will do some power testing specifically with this transformer that I'm having here. Isolation transformer is called, and it's not a switch mode switch mode transformer. It's not switching anything. It's an isolation. Is only transforming the electromagnetic field. So most probably I will use this rectifying bridge. These legs are, but this is some form of coating, or it's just the copper that is oxidated and it becomes black like that, or darken, browner, dark brown. That's what I'm having here. And it wasn't having this chrome or nickel plating of the legs, and these are copper legs as well, most probably, like this one that is having here. So that's it about this bridge rectifiers that I have, and this is my plan, what I'm having here, to use this bridge rectifier, because, and let me draw it here. Yeah, here it will have like this, the sine wave, because it will not have this lower, so it will have like a gap here, and here it will actually have the full I'm drawing here the alternative path, but on the rectified side it will be like this here. And then if I will add a capacitor, here and probably a resistor somewhere. I will smooth it out better. So I know for sure using this bridge rectifier is way better than this. Only one diode or two diodes like that is not really, it's not that efficient what I'm having here. And this is what I'm having here, and this is with this bridge rectifier. So I'm highly recommending using every time using a bridge rectifier like that for all your projects that involves transformers. I learned this a long time ago. Yeah, that's, and also I will add shorter wires because these are very long and stupid wires and I don't need them to be this long. And they are very thick actually. They are very good because they are very thick. That's it about this transformer. All right. Next, I will have to actually measure everything what I'm having here. Actually, I should make a quick test. Yeah, these are horrible here. They are looking horrible, but I can clean them. I'll try not to cut them because it is material and I cannot put it back. And it will become wasted material if I would cut it back. But I can try in cleaning them good enough to make, and actually solder them and put them into a plug here to connect to the 240 volts there. Yeah, I will have a little bit of work to do for this transformer, but when it's done, and if it's working fine, it's a very good device to have for my projects here. So basically, I wanted to show it, to present it in its unmodified stage it is right now. That's why I made this beginning movie of this transformer, what I'm having here. All right? All right. Yes, I want to show you how long this wire was here. This isolated wire was made a small ball here and here a couple of minutes ago, and I unwind it and I clean it with my knife, with my trusty knife, on this block of wood here, and I scribe it like that, and I cleaned all that nastiness from this ends of the wires, and they are looking shiny and brand new copper like that. But I wanted to show you how long it is. You see, compared with my finger, it's very long, and actually it's a problem when I'm having it this long, when I have to connect it into a plug. But I will probably find a way not to cut it and keep it as it is, and adapt it to the new plug that is having. That's it for this is what I wanted to show, how long it is when I unwind it from there, instead of cutting it. All right, so this is my resolve here. This is my plug that I'm having, and it's having this hole here and the screw. And what I'm doing, I'm passing the wire through here, okay, through this hole, a little bit, not much, and I'm screwing it here, because I'm screwing it here in this margin, and I'm screwing it hard. And also here again, to be sure it's hard enough it is. So because usually the screw is having the tendency when it's screwing this wire to cut it off, and if I'm screwing it here, it will cut off a large piece, while my intention is to leave it as long as possible and not cut it. That's my intention, not to cut it, you know. So this is what I'm having here, and let's see how it is doing here. Fortunately, I'm having this little thing which is very, very helpful actually, and I will use it. It's very helpful, and you will see in a second. And right now it's looking very, very dodgy, and it's not really recommended to use it like I'm using it here. And you should not make such improvisation like I'm doing. Leave only Romanians to do it like this, like that. It's having actually a notch here, and it's fitting there like that. These flying wires are a big problem actually, usually. Not to touch on the other side, that's the problem, you know. But it's a very large distance between the two, and I am careful. I can put a piece of isolation here actually over this and this, but I will leave it as it is. So now this is very, very helpful actually. It will press the wires from dragging out, and I didn't know I have it like this. I was thinking I will have to improvise something along the way, but this came very, very handy in securing the wires. Usually very, very smart idea to insert it into these plugs. Before, in the 90s and 80s, this thing wasn't an idea back then. This is an idea in the 2010 like that, and it's a very good one, very practical. And here I will, because this is plastic, I don't, if I'm screwing too strongly, it will eat the plastic. So I am at the limit of how strong I'm screwing that screws. Here I'm making sure this will not move. Now it is having no chance. Well, it is moving here, but it's having absolutely no chance of flying over there. It's looking very dodgy. It's looking like very, very dodgy, I know, but it's good. It's good enough. Oh shit, I forget this motherfucker. Shit. This is motherfucker. Yeah, it is helping a little bit, this little shit. I can put it without it. I can put it without it like this. Nah, it is really helping. Shit, I have to take out everything and put it again. Motherfucker, I forget. I always forget that motherfucker. This time you'll see the entire process. Let's, like this, like this. Motherfucker. So this motherfucker. And I need it like this to be inserted. What is a little bit dangerous of this long wire is that pieces, very small pieces of wire can get out of it and potentially make a contact inside there. Just flying around, just breaking up because it's twisted like this, and from this twisting, some little bits of copper may fly away. And yeah, this is quite snuggle here. Very good, actually. This is very good. So that's a problem. And I will twist it again. Yeah, and this one as well. Yeah. Yeah, it's not a big philosophy here. I'm doing it once again. Nice. All right. This movie was longer than it had to be. Okay. This is looking very dodgy. I don't like it, but well, when you are trying to salvage everything, you will do stuff like this. This is reality. This is what you are doing in reality. That's it. Fine. And this other one with this little helper that is having there. Yeah, probably, you know, the second time is better than the first time. Like that. Something like that. Okay. And this here. A little here. A little here. A little here. And voila. It is completely. Let me check it again. If for flying. Yeah, you see it? Yeah, there. These little fuckers, they potentially can make a very nice short, but they will have to be quite long to gap this two, so I will not be bothered about it too much. I think it's safe enough. I'm playing as safe as I can, you know. And here, this thing, this motherfucker, here, and this one like this. Yeah, all right, now it's good. And this is how you transform a very old cable and restore it to a functional one. Yeah, that's it. So it's a perfectly fine cable. You don't have to throw it away to put a new one, because why? Because it's looking ugly. This is stupidity. This is capitalistic stupidity. When you have to throw away something that is looking old to change it with something that is new. No, it's having the same copper inside, the same material. If you are lucky, usually older stuff are more resilient and way more better built than the newer stuff. Newer stuff are cheaper and thinner and more breakable, and older stuff are better. Trust me on this. This is a universal rule. You know, older stuff from 90s and 80s. And even further in time, but after 2000 stuff got very weird. All right, that's it on creating this plug. I hope it's helping someone the way I'm doing things. All right. I forgot to mention that I actually wanted to show you the construction of this transformer that I'm having here and how it's made with these two diodes here. It's a smart way of rectifying and transforming this alternance into a continuous current through these two diodes here. It's a interesting build, you know. That's why I film it and I explained everything, how it's linked and wired here. It's a way of doing things, but this is not the way. The proper way is using a rectifying bridge, like I will put in a moment. I'm having these two output wires here that are coming from here, so I squeeze them here in this vise, not to move, and to be able to actually measure them. And here I desisolated this other wire, and I already made all the measuring, but I will film it as well. I will only show the measuring on the device, but I will work somewhere there and with this wire as well. And all this time this transformer was plugged in and nothing is telling me that it's plugged in. A LED, an indicator LED or something. That's why it's very good to have indicator LED once a device, especially a transformer, is plugged in. So right now is alive. I'm measuring on this end, but my phone cannot reach there, so I'm testing between these two actually. Let me actually do it like this. So I'm getting 3 volts here, 2.6 volts, almost 3 volts between these 2 points that are already linked here. And between this wire, so what I'm having is here, between this and this actually, what is linked here on these two terminals is here and here. Why? Because it's 3 volts here, but here it will be a little bit bigger. You will see in a second right now. So this one, and here is 5 volts. So 4.8 right now at this point. And here is 2.3. I believe I got a 3 volts here as well, but yeah, 2.3. So this two here I'm measuring correctly, here and here actually, 2.8, and here is, between these two is, so 4.8, is 4.8, okay, and now, between this point and this point here, 2.9, so 2.9, and between this one and here, 2.3. 2.3. There is some losses somewhere, I'm not sure where. But another readings, it gave me 5 point something, 5.3 or something else. So this plus this should give you this, the sum of this. So 2.9 is 3 almost, 5.2. It should have been here, 5.2. So it's, yeah, it's some losses here from somewhere, I'm not sure where. Probably I'm not making absolute good contact. So this is the reading, the test reading of this specific transformer that I'm having here. It's not great for what I need, for my test that I want to do here. It's giving me these 5 volts that are usable, and probably, I'm not sure how much amperage I can get out of this. The wires are not that thick, these secondary wires are not that thick, so it's probably 1 amp. Let me actually measure it. This is directly the wire that is coming from the secondary. This is the winding wire. 0.6. So it's 0.6 diameter of this wire. So 0.6 diameter of wire. This is letter phi, is the designator for diameter, usually, is from my very old knowledge. So that's the secondary, the sec, millimeter. Diameter. I will have to look and see exactly how much amperage I can squeeze out of the 0.6, but probably around 1 amp, kind of powerful. Right, so I got rid of that transformer before, and I find another one. This is very clearly scrapped from somewhere, and I believe, if I remember right, this transformer I scrapped it specifically for the copper wire to get a source of copper wire from it. I believe that's that's the reason I scrapped it, if I remember right. But now I tested it and I was very worried. I didn't know which is the primary, which is the secondary. I literally had to take a guess. I actually test it like this with my continuity tester that I'm having here, specifically made for wires, that is putting actually 9 volts here on these ends. And if I'm testing these 2 wires here, you can see that LED is lighting up. This is a buzzer, and if I am doing this, you can hear it. But here, because it's having so many windings, I can only see the LED lit up, because that's a very sensitive LED, very sensitive. So I'm feeding him probably a couple of microamps of power, and it is already and is able to lit up. So I'm very lucky of that one, of that LED, because the buzzer is not buzzing anything. This is testing one set of wires. Like I'm having here, I'm testing this primary side, this test of wires, and this is not having this 3, is having only 2 of them, and is very clearly I had to take a guess which is primary and which is secondary, and I was a little bit worried when I plugged this theoretically primary winding into the 220 volts. I was imagining how it will get in flames and in smoke here, and it's helping very much actually to expect something will blow up, but nothing blow up, so it was quite a nice surprise. And then I measured the voltage over, but let me show you now my tester, and here is actually beeping. You can hear the beeper. So this is telling me this is less windings here. So I called this as the secondary, these 2 ends as the secondary for this specific transformer. And I also tested the continuity if the wire is interrupted somewhere, and it's not with this little tester that I'm having, and I'm using it quite a lot. And now let's make the voltage test here. And I can hear it humming actually. I can hear like it's doing that 240 volts hum. So now it's a little bit more quieter because I was having my fan open. So when I'm measuring, let me plug it in, and you can hear it. Probably you can hear it humming. Yeah, and I'm getting that 13 volts. But this digital multimeter is not that good. It's giving me a little bit higher voltage when I'm measuring. So I will use this one on alternative here on 200. And I'm trusting this one better than the other one. Yeah, 13 volts. Huh. Okay. Excellent. This is very good actually. This is very good. And probably you can hear it. Let me close this. Do you hear it? It's humming a little bit. So let me close it, take it out from here, and check if it's if it's hot, and it's not. I took it off, that's why I'm putting my hands all over it right now, and I'm testing if it's hot, and it's not. So it's a good transformer, actually. It's a very good transformer, and it's totally scrapped from God knows where. Unbelievable, unbelievable. And I have it thrown away in my pile of stuff, of junk components, for a very long time, probably from my adolescence. I'm having this scrapped from somewhere, God knows where. Yes, it's very good, very good transformer. I'm very happy that I'm getting this 13 volts, because now I can test a bit more serious power on my MOSFET, on this guy here. We will see next time when I will actually transform this alternative ends voltage into DC voltage with probably with this bridge rectifier, and probably a smoothing capacitor as well, and a little board that I will glue it somewhere there probably, and I will drag the other wires, some other wires that will represent the DC voltage from this, and also make a note there what is what. All right, I'm very happy with it. I had to add this new cable to this. This is also scrapped, and I am very pleased with this cable, because this is rubber, and usually rubber is solidifying, is cementing itself, is becoming like a cement, very hard, very brittle with time. Certain types, certain mixtures of rubber are getting very hard with time, but this one is very old and extremely malleable, very soft rubber, or I suppose it's rubber, is rubbery, and it's very soft, and it's very old, very shitty when you look at it, when you first glance it, and you don't give a shit about it, but it's extremely good, both in elasticity, and also is saving copper wires. Also, this transformer I don't like, because I'm seeing on its primary here, and I'm not sure how well can you see this. Can you see it? Like this. Here, this wire, this white isolation, and here as well, underneath it is the wire is not copper, is steel. It is a steel wire. I try to I thought it is nickeled on the outside, and I try to put a little bit of solder on it, and nothing sticks to it, and it's not either is not aluminum wire either. It's actually steel wire. It's a very weird transformer. Very cheap transformer, probably they used, or only these ends are the steel wires, and underneath is actually copper wire, who knows. But it will I will have to solidify somehow these two wires, not to bend too much. I will bend them into a finite state, and then I will drag some other, I will make a terminal from where to drag other wires from, not to link them to these wires, to protect these wires, not to bend until they will broke. Already it's hardly bent here, and is not a good thing. Okay, that's it about this transformer, and I'm very happy for its 13 volts alternative, and when it will be continuous, it will drop probably 1 volt, so it will be actually 12 volts. So this is the update. I'm rewiring this transformer. I'm making a better connections, better wiring, clearer wiring, because everything here in the front was all around. So now I'm leaving all these 3 outputs in the secondary, and this is the primary, and I dragged these red wires here, and I put again this cable. Here is 2 pieces of cardboard, and I made a small hole in this top cardboard that is glued on the other one, and for these pads, they are very thick pads actually, and I soldered the wires here, and on top of it, because you can literally touch it like that with your finger, and I will put on top of it this plastic shield that I made it right now to fit what is here, and I changed the screws here to a longer ones, and better here on the other side, and this will have a double role, one of protection and one of pressing very firmly this wire that is always dragging. And I purposely bend it like this when I'm dragging from this wire, is a bit more harder to get loose from its soldering that is having there, or to crack the plastic. So that's why that bend is adding a little bit more strengthening, you know. And after that, I'm putting these 2 screws, and that's it. And the transformer itself is already secured by these 2 nuts here, and they are creating a little bit of heightening, which I don't really like it, but it's okay in the end. The pressing here will be good enough. I can put something here to add a little bit more pressure, like another cardboard or a piece of wood or something, you know, non-metallic, of course. So this is my result for this side of the transformer, and on this other side I will update you soon. All right, a small little important update. I put an LED here. I already had this LED scrapped with this black case that is having this black plastic case. So it was inside it, and it's quite hard to get it out, because it's having a little this guy here, this little notch that is is like a clamp that is keeping the LED inside. So I try to take it out, but I leave it there. And this little plastic is having, you see, this kind of, is having 2 pins there and a little leg. And I made this metal support, and I made a couple of holes inside this metal sheet, and I bent it like this, and I put a matchstick here when you press on it, not to deglue from here, because this side here, all this side here is glued to this surface. I use sandpaper and I clean it a little bit, and this metal, and I use Poxypol. Don't buy Poxypol. Don't buy it. Do not buy it, because it's kind of, it's bad and good at the same time. It's good and not that good. And this matchstick, I used Prelandez, and here I used diode that is pointing towards positive leg of the LED. And here is 100 kilo. You can barely see it, but it's there. Here it is. Here is the end, and the other end is inside this tube here. And here is a very long leg of the resistor, and is naked. And this wire is linked to that naked leg. So I put this tube here to not leave that metal, visible. And also here a little bit of protection. This is a sleeve that I can pass it through the diode, over the diode. And here another little bit of plastic tube. And that's it. And I'm planning to add something here to protect this this bending that is putting a little bit too much force on the leg of the LED there. So it's really not good to have this stiffness here. So I'll have to do something about it, probably. I'm not sure yet what I will do. But so far so good. I made a test already, and it is, let me plug it in, and when I'm plugging it in, is telling me that this transformer is powered online. Here in the video probably is visible some sort of flickering, but by the naked eye is not flickering at all. So it's quite okay. The idea is to have a signal that this is powered, because until now I didn't know if it's powered or not. So this is the quick and dirty modality of telling me this is plugged in. It's important for me. It's important to have this kind of details. And here I will have to put this thing here, and then come on like that, and then press it and screw it, and that's it. This side of the transformer. All right, and here it is, the construction. I put back this cover, and it's a simple cardboard that is, I took it underneath so it's quite long, like until here, and it's underneath the transformer there. So it is kept without moving between the transformer and this wood support or base. And here on the top, this cardboard I folded, I glue it there, these 2 pieces, and then I sew it. And then this top part is acting like a spring, and is I can move it like that a little bit inside. It's not perfectly flush with the wall, but it is holding by itself in this in this position. So I made use of that little gap there. And this of course they are 2 bridge rectifiers. They are both scrapped from somewhere, and I had them next to the new ones, so I didn't reach the new ones yet. And as you can see, this is a little bit more fat, and this is a little bit more slim, so they are different brands basically, but doesn't matter. What it matters is that they are working. And I put the voltage. I already measured everything, and it's working quite nice. And right now when I'm plugging it in, the red signal LED is warning me this is alive, and I should not put my fingers here on the other side. Here is my voltmeter. I already set it up to 20 volts here. I hope I can. No, I cannot do it with one hand. Yep, 9.7. There you go. So 9.7, and it is marked there, a little plus. You see, a little plus and a little minus, and there as well. So yeah, I'm using these as outputs as they are, and this is 4.8, and it's exactly the same voltage that I wrote there, because I made this measurement already, and is ready to go. It's ready to be put in use. I really like this top signaling LED. It's very retro, and that was the idea. Pretty much I like retro stuff and retro looks, and this is looking quite nice and quite weird. Probably I will not need this frontal side. I will see if I will keep this piece of wood, which is dangling back and forward. The surface is bent with time. It got bent like that, probably. Yeah, that's it. This is it for this transformer. Is working fine. Before, if you remember, I got On those two diodes, I got very different voltages. I got 5 volts and 3 volts for here. So something was wrong. Most probably with those diodes, they were eating an excessive voltage drop over them, and this is how things should look and work, like I'm having here. So it turned out the transformer is a little bit more higher than that 5 and 3 volts that I was getting originally. So never trust an old equipment because it might have some devious or tired components. Most probably those diodes were tired components, or stressed for some reason. So yeah, this is it. These are almost brand new. Even if they are scrapped, they are mostly brand new bridge rectifiers, and I probably oversized them here. The amperage that I will need from this transformer. Actually, I will need quite a beefy amperage from this transformer. I'm not sure how much amperage I will get from this output wires from its secondary, because they will dictate the amperage. These bridge rectifiers that I'm having here, they are on the line, but they are a little bit oversized, most probably for this amperage that will come from the secondary here. And I have the other transformer here, and I didn't try to do anything with it yet. I concentrated solely only on that one, and I'm very happy that I'm getting this higher voltage here, because I can use it to test my MOSFET, that one there, for a higher voltage, pretty much. It needs to have two separate voltages here. For the driver, 1 voltage, and for the MOSFET transistor, another voltage, separated from the first one. If this arrangement, 2 coils from the secondary, will give me problems while I will drive that MOSFET, because that will suck a lot of power when I will drive it, then I will use my power supply that I'm having there, actually, to drive the circuitry there, to drive the gate of the MOSFET, and I will let all the power from this transformer be sucked by that little MOSFET that I'm having there. This is only for testing purposes. I will not say anything about practical reasons. We will see later, after the tests are done, and when I will call the test finished, and after decide what I needed to get out of this test, this entire test that I am performing, that I will perform. All right, that's it. Thank you very much for watching, and see you later. I hope you liked my transformer video so far. All right, leave a like, and bye-bye from your favorite artist electronist, Mr. Q12. Bye-bye.